Number 79, letter A. Echo times are measured by diagnostic ultrasound scanners to determine distances to reflecting surfaces in a patient. What is the difference in echo times for tissues that are 3.5 and 3.6 centimeters beneath the surface? All right, so basically, in order to do this, right, remember that when an ultrasound is sent out, right, the signals will hit a certain object, basically, and then will be reflected back, all right? So basically there's going to be two, the distance here that it travels is going to be 2 and then back. So the time, if I were to find, let's say, the time of one path, okay, that means then I'd have to multiply that by 2 to find then the total return time, right? Because there's really going to be 2 times, all right, that we'd have to take into account. So what that means is that I can basically use a simple formula here that the velocity is equal to the distance divided by the time. Now specifically the velocity through what? Well, through human tissue. So that's about an average of 1540 meters per second. So that's now going to be equal to the change in distance now. Well, the change in distance is simply going to be the difference between these two distances, right? Those two depths, divided by then the change in time. And guess what the change in time will be? What it will mean, I should say, if we use those change in distances, well, this will then be the time difference between, or I should say the time difference of one path, right, of only traveling to the border, not traveling back. So then all I got to do is basically take the answer and multiply it by 2. So this is going to be 1540 is equal to then, and we should have this in terms of meters, right? So we'll take the larger one. So this is going to be 0.036 minus then the smaller one, 0.035, all then divided by then the delta t. Solve for delta t, just do a cross multiplication. So it's going to be the difference in the distances. So 0.036 minus 0.035. Then divide that by now 1540. And what do we get? We get a delta t value now of about 6.49 times 10 to the negative 7th. But you got to multiply that by 2 because we're talking about a return trip. So multiply that by 2. And now here we get a value of about, so the delta t will be approximately 1.3 times 10 raised to the, times 10 raised to the minus 6. All right. And that's basically going to be the relative time difference between the two. All right. So guys, thanks for tuning in. Hope this helped. Please remember to subscribe. We'll see you soon. Bye.